my name is Bryony Turner and I coordinate and manage the Space for Climate group. We're a group that unites UK space-enabled climate expertise and services. We're chaired by the UK Space Agency and our members are from government departments, from industry organisations, from the sort of small startups through to big multinational firms, and we have world-leading scientific experts on our group. We work sort of internally in the group to identify any challenges to the climate data supply chain and to ensure that we can continue to provide a seamless supply of trusted climate intelligence from space, and that the UK does offer a thriving and supportive environment for doing so. But externally, and really what I'm here to talk to you about today, is how we connect our UK producers and our sort of experts in this area with global users of trusted Earth observation data. So our group spans capability and functionality right from mission concept through to what I call value added services, so providing climate data support. And I just wanted to dwell on climate services as an area that is expanding, to say that we're seeing increasing efforts towards professionalisation of climate services. So in the UK, there are British standards that are in development. I know that there are ISOs already in production. ISO 14097, 90, 91 and 80. If you don't know them already, do look them up, around climate change, adaptation, mitigation and net zero and reporting. And obviously there's the Global Climate Services Framework, which I've extracted the definition here from. And here in the UK, Space for Climate is part of the UK Research and Innovations Climate Resilience Programme project, specifically on climate services, standards and value. So looking at, how can we make the provision of climate services robust. Obviously, Space for Climate is interested in the role then of the climate data supply chain in providing sort of traceable, where necessary, sort of kite marked information, and how we then ensure that our data that we're integrating into the intermediaries that are making use of it, and where our groups are actually delivering directly climate services themselves, that we can do so in a robust manner. I think that it's important to note that we're shifting from making do with the data available to now having investment in instruments and capacity and capability to provide robust sources of climate information for government, commercial and third sector needs. And we're shifting from retrofitting models derived for climate science needs to commissioning modelling and analytics built for user-defined problems and decision complexity. And that in itself has some challenges when you're working in the climate data supply chain, whether you're doing that from a scientific basis or a commercial basis. We're shifting from designing for an end output to designing for operation over a lifetime of a particular, so say you've got the built environment, the data you might be using to inform the design of it or the redevelopment of a building will be at the very least looking at the kind of climate challenges it will face over its lifetime. And with the circular economy in play, there'll be many types of sort of physical assets where we'll be looking to see how they can then be reused into something else. So just giving that as a bit more sort of tangible, but that's an example where you might be using both and needing to use both sort of historical climate information as well as looking at the climate projections and sort of scenario testing within it. I think it's also important to note that the framework and principles for assessing and reporting investments and financing activities relating to climate change is changing, and this I'll come back to the role of the financial chain in driving new types of climate services requirements, right from missions to analytical tools. I think what I want to just start with in terms of giving you an insight into what the space community is doing, or certainly in the UK, is to say it's really, really important that the international space community plans today for the missions of tomorrow, because those will be supplying vital information for future generations to be able to continue to understand, monitor and take action on Earth's climate. So I've drawn out here methane and a little bit of what we're doing on that. It's an important greenhouse gas. It's actually 86 times stronger than carbon dioxide. It's increasing in the atmosphere due to human activity, and the difference, well, there are many differences, but one of the differences, it doesn't persist in the atmosphere for a long time. So the kind of role that climate satellite data can play, really we need to get that data from looking at kind of trends of sort of what's happening over time to where's it coming from, and how can we very quickly intervene if we see a high concentration, a source, to take action to reduce its presence in our atmosphere. For that you need high spatial resolution detection, and that's where the technology is not just taking us, but has already taken us and is improving. So you really need a kind of ground resolution for that kind of point source detection of better than 100 meters. I've listed the kind of new technologies that are coming into play that CEOI made me aware of, that are really revolutionizing being able to deliver on that requirement. Some of you may be familiar with GHGSat. That's a Canadian commercial company which also has an office in the UK. And that already has, I think it's around 3 satellites already sort of taking high resolution imagery and able to identify industrial sources of methane, and they're planning to expand their constellation. And then NINCAN is a mission concept under development by the University of Edinburgh, and that instrument is suitable, will be on small spacecraft and large CubeSats. So we're starting to see basically more types of sensors come into play and be available, and that will have a ground sampling distance of 60 meters and a huge width, a 30-kilometer swath. So this will really change the way that we can image and monitor and understand methane release plumes on the ground from anthropogenic sources and help take very quick action. So we've also got missions that are planned for carbon dioxide. So that's another important greenhouse gas emission, and I'll just point you in the direction of this one, which is a joint UK-French satellite mission. That will measure sources and sinks of carbon. That includes within cities, and actually has a special city sweep mode. So I can't dwell on this too much, but I think it's really important that you're aware of the new missions that are being planned and conceived right now that will change the kind of data we have within the next couple of years. So satellite data from space, you know, I've talked about new missions, but it's actually already used. It is integral for systematic monitoring of Earth's climate system, and for scientists investigating the physical processes in the current climate, including how climate has been changing in the recent past. We need long and consistent data records for our land, oceans, atmosphere and cryosphere. And in order to make decisions on climate change mitigation and adaptation, the United Nations Framework Convention on Climate Change requires systematic monitoring of the global climate system. And what you can see here, an outline of some of the essential climate variables from the European Space Agency's Climate Change Initiative. So that initiative produces long-term observations around sort of 40 years worth per climate variable, as mandated by the Global Climate Observing System. That's run from ESA's Climate Change Office based in Harwell in Oxfordshire in the UK. Those data sets going back 40 years produce climate data sets that the scientists and world leaders rely on for predicting how our climate is likely to change in the future. That's used in climate modelling, the frequency and the impact of extreme weather, the information is also used to make crucial decisions today to protect the environment and society, and I'll give some examples in a bit. It's just to highlight that the UK is involved in, I think, over 21 of those essential climate variables and related projects. You can see the ones the UK leads on and the ones that UK is collaborating with the international partners on through the ESA programme. So for any of you out there in the research network that are interested in using these climate satellite data sets, if you can see it's one that the UK has expertise in, do feel free to contact me, and I can put you in contact with the right people. So I just wanted to highlight that the kind of analytics chain of the climate data supply chain is also advancing. I won't dwell on this too much, but just to say the digital twin technology is not just for, you might have heard of it in relation to the built environment context, perhaps in terms of sort of just-in-time information for building operational management and how infrastructure systems are working. Well, in the space world, there's a huge ambition, which is to have an interactive real-time representation of our entire planet and its complex processes. And the European Space Agency has a flagship Digital Twin Earth initiative, which some of my group members are involved in, and Telespazio UK are involved in the Climate Explorer, which has been exploring what's needed and how we can perhaps deliver on that ambition in practice to generate and visualize in real time decision-ready information relating to the regional impacts of climate. And lastly, I wanted to give you a taste of where climate satellite data is already in use in a decision support tool that is enabling decision makers to take climate action. So here we've got the example of RESAT, the Renewable Energy Space Analytics tool funded by the UK Space Agency, delivered by the Institute for Environmental Analytics. And satellite data within this is combined with ground data, and it helps with a lot of complex analytics to identify the best renewable energy mix. So obviously that helps the small island developing states that are utilising it to make progress on their transition to net zero. But what I really like about this, and what I think is really interesting, is that the climate satellite data involved with it also helps with the sort of simulation of climate scenario, different simulation to help plan a renewable energy mix when the downtime might happen, if there's increasing frequency of storms under a changing climate, changes in sea level rise, changes in solar availability, changes in wind. Obviously satellite data is not the only data set that's helping to do that, but I think this is the really exciting type of sort of analytics climate service that we should be seeing a lot more of, where we've got tools that help net zero action that is climate resilient or is adapted to the level of climate change we are expecting. So I referred earlier to the push that we are seeing coming from the financial chain. Part of that is very much coming from the Task Force on Climate-Related Financial Disclosures that reported in 2017. Over 2,000 organisations from 78 countries already support these recommendations, including over 110 regulators and government entities. If you're not aware of them, do go and look them up and become familiar with them. They do require reporting on emissions, the transition to net zero, but also on the physical risks posed by climate change under different scenarios to assets and operations. And where the financial chain starts requiring that kind of information, so it will require it from the organisations it's investing in, funding and involved with. So that will push the global chain alongside the efforts by international community and policymakers, and hopefully the very positive actions and outcomes that will come from COP26, which is going on at the moment and over the next 12 days. I wanted to mention that the systemic changes that are required and the kind of data and information supply changes that kind of triggers should not be seen in isolation of the ambitions and efforts around sustainable development. You cannot have sustainable development if it's not climate resilient and if it hasn't considered the implications of climate change that is occurring. So that needs to be borne in mind, and I draw your attention to the Dasgupta review, which called for fundamental change in certainly Western economic systems, that the environment should not continue to be externalised, and that does, and the kind of challenges the growth trajectory. So there's all of those kind of wider things going on that are really pushing this kind of climate information flow. And that means we're seeing a change from climate data products to form mainly science and to what I've sort of outlined already as climate services. And that presents challenges for the supply chain. and one of the most important challenges is actually early engagement and scoping with not just the willing players. So perhaps some of those financial organisations, the insurance companies are very hot on using climate information, but actually those that are in different localities and in different ways are able to take climate action and or test out their own knowledge systems. And by here I reference also Indigenous groups as well, so I'll come back to that. There are the challenges around also continuity of access and continuity of provision. There's a lot of interest in funding new technology and new projects. There is very little interest in actually funding the continuity of provision. And with the climate data sets, some of the ones I talked about earlier and the scientific, the ESA CCI ones, we need to make sure that the international communities, there are tough times with COVID ahead, that actually they are and they do understand and will continue to invest in the provision and the maintenance of those data sets as open access, so that we don't end up with intelligence biases from our global observing system, where it's only those that can afford to purchase data sets that can actually then use that information to take action. And I think also I'd say it's highlight that it's actually also, along with continuity of provision and a service provision means integrating into improved iterations, feedback from users. So coming to the end of my presentation now, one of the first things that's important to do is start mapping what's already available. We've done that as an example for the finance chain, do check it out. But then actually it's making sure we're picking up on the learning already, and particularly in terms of weaknesses in the climate data supply chain for inclusivity. And we ran an event with the Global Partnership for Sustainable Development Data back in June. We've got a report online which you can see, and I really, really encourage you to look at it. There were challenges on, if this, who actually has the power to access this, or even the awareness of knowledge to then, even if the data sets are open access, how do you become aware about it and be skilled and equipped to be able to then use that information? So are we creating an unconscious bias through the unconscious bias in which we actually deploy the data supply chain? I was interested to see that in Australia there is Aboriginal ground segments, so that's the kind of ground truthing and where some of the satellite data is received. In Alice Springs, as an example, the Group on Earth Observations has an Indigenous alliance group that helps us to inform this. So it's not that the space sector isn't doing anything, but I think what we'll see increasingly is as we get this kind of climate service requirement, if we are keen to make sure that globally we make this information and keep a lot of it open access and free intelligence for people to use locally, then we need to think about any kind of inherent biases in our system, in our procurement chains, to think about who is actually able to access this open data and these open products that we're producing, and how do we maybe do more. And I think that's where the role of partnerships like Space for Climate, like Global Partnership for Sustainable Development Data are integral really to broker between the scientific community, different local populations with different needs, and then those from both science and industry and government that can take those decisions along the climate data supply chain to meet those needs of today and of tomorrow. So thank you very much, and see you at COP26, either in person, we have an exhibition space, or virtually. Do look at our website for more information.
I'll be speaking about some research that I've done on environmental and sustainability issues that uses restricted microdata that's available in the Stats Canada RDCs. And so my research agenda in general, as well as the research that I'll speak about today, really focuses on two streams. It's all environment sustainability related, but the first stream really asks how environmental regulations shape socioeconomic outcomes. So in this kind of inquiry, I'm going to be looking at, what happens when we implement a new environmental regulation? How does it impact the people that are regulated? And the second stream of work that I do is looking at what the impacts of environmental change are on socioeconomic outcomes. So if we see more air pollution, for example, or if we see changes in the climate, how does that impact people's well-being? And so I'll speak about both of these two themes with a couple of examples of work that I've done in the RDCs over the last few years. And the first theme, again, is what happens when we regulate environmental outcomes, and how does that impact socioeconomic outcomes? So I've got a couple of examples here. The first one looks at a really prominent regulation, and this is the carbon tax that was implemented in British Columbia in the year 2008. And so British Columbia was one of the first regions in North America to implement a significant carbon price, and it has really been, I think, an inspiration for a number of other regions. In particular, the Canadian federal government has followed along some of the design choices that British Columbia made in 2008, and it was a real precedent-setting regulation. And so in this couple of papers that I'm going to put up here, I, with some co-authors, tried to understand how this regulation impacted households in British Columbia that were subject to the regulation. And what we did was coupled a computable general equilibrium model, which is populated with the data from Canadian System of National Accounts, with detailed household accounts data, which came from restricted microdata from the Survey of Household Spending. And so we used this model to simulate what happens when a carbon tax was applied and try to understand how the incomes of different households were affected by this policy. And so I've got a bunch of graphs here. The top left figure shows how we think this carbon tax impacted household incomes. And what I'm showing on the horizontal axis is different households from across this income spectrum. So households at the first income decile or the lowest income decile on the left, and households in the highest income decile on the right. And what we're seeing is that this green dashed line shows that although households spent their income slightly differently across different levels of income, those different patterns of expenditure, so for example, some people spend a lot of money on gasoline and some don't, and some people spend a lot of money on restaurants or eating food out and some don't, those different patterns kind of didn't result in major differences in effects from this policy across different levels of income. But the fact that households earn their money differently across different income deciles really has a marked impact on the way that households are affected by the carbon tax. And so the richest households at the highest income deciles mostly earn their money from capital income or investment income, as well as from labor income. And because those are likely to decline, the wage rates and the income returns on investments is likely to decline somewhat under the carbon tax, they experience the higher income loss from the carbon tax than households at lower income deciles, who are more shielded from those impacts because they derive a lot of their income from government transfers. And so we see this overall progressive impact of the carbon tax on the distribution of income, where lower income households don't experience as much loss as higher income households. In the bottom graph, we also couple the carbon tax in our model with other policy changes that were made at the same time. And these are notably the revenue recycling, what happened to all the revenue that was raised by the carbon tax. And what we see when we incorporate those revenue recycling is that households at the lower income deciles, the poorer households in British Columbia, actually experience income gains as a result of this policy, whereas households at the higher incomes experience very modest income losses. And so this is showing us that, first of all, the policy is progressive. It affects the distribution of income in a positive way. Secondly, up to the median household, we mostly see income gains as a result of this policy rather than income losses. And where income losses appear in high income in households, they're small, 0.1 or 0.2% of income on average. The second study looks at kind of the same issue, but comparing rural and urban households. And what we see when we incorporate all these different sources of income loss from the carbon tax as well as the revenue recycling is that households in urban and rural and peri-urban areas, the green and the red, experience larger income gains as a result of the carbon tax policy than households in large urban areas. And this runs contrary to some of the narrative that existed around the policy, and I think is interesting as a result in its own right. The second study that I want to talk about that looks at kind of the impact, socioeconomic impact of regulation, is a study that was done with a student, Sarah Shenstone Harris, as well as a colleague, Nathan Young, and looks at how the effort by Toronto City Council to reduce single-use plastics played out. And this policy, this effort was started in the year 2008 when Council implemented a levy on plastic bags used within the city that required all retailers to impose or to charge 5 cents when plastic bags were used. And it was revoked in the year 2012 as a result of an argument in council. And so we have this nice kind of quasi-experiment where some people in Toronto were exposed to a levy for a certain number of years, and there's nice counterfactual where other people outside of the city weren't exposed to the same levy. And so we can compare, try to understand what happened as a result of this policy through comparison. And this graph kind of shows visually the comparison. It shows that, you know, the plastic bag or reusable bag use was similar in Toronto and the rest of Canada prior to the policy implementation. And then reusable bag use jumped up when Toronto implemented this policy, but fell back down in Toronto when the policy was revoked. So the data for this study comes from the Households and Environment Survey. And overall, we found a 3.4% increase, percentage point, I should say, increase in reusable bag use in Toronto as a result of this policy. I think the interesting thing is happens when we dig into some of the heterogeneous impacts of the policy. And so I've just shown you some of these on the right. And what we're seeing here is that the response to the levy in Toronto, the positive response, was really concentrated in high socioeconomic status households. And so households with high incomes seem to respond to this levy by increasing reusable bag use, but other households, lower socioeconomic status households, didn't. In fact, in some cases, there's evidence that they actually negatively responded to this policy. And we see the same kind of general impact when we cut socioeconomic status in different ways, whether it's by education or home ownership, for example. And it speaks to kind of how the effects of environmental regulations may not be perceived identically by all groups. Okay, so that's a really quick run through of some of the research that I've done on environmental regulations. As I said earlier, my research kind of encompasses two themes, and the second stuff I want to talk about is trying to understand the effect of environmental change on socioeconomic outcomes. So what happens when we see changes in the environment? How does that affect socioeconomic outcomes? And so this first research paper is with a graduate student, Philippe Cabor, and it's under preparation still or under submission. And what we do is we use data from the annual survey of manufacturers and logging. And so we're able to follow about 60,000 manufacturing companies over time, over a number of years. And we use the geolocation information in that survey to figure out what weather each firm was exposed to in the years for which we have data for that firm. And following similar literature, we're able to figure out that firms in Canada that are exposed to extreme weather produce less output when they're exposed to more extreme weather. And so that's what this graph on the left shows. It shows that when firms experience extreme hot weather or extreme cold weather, their output is reduced, that they're able to produce less output. That's an important finding, which suggests that firms, even though they're operating mostly inside, are susceptible to changes in the weather or the climate. So we take this set of estimates that we get from the annual survey of manufacturers and logging, and then we use data from a number of climate models to think about how the climate might change in the future. And what that suggests is that we're likely to see in the future many more days of extreme hot weather. In fact, the firms in our sample currently experience about 12 days of what we define as extreme hot weather per year on average, but by the end of the century, under a warm climate scenario, we expect them to experience as many as 80 days on average of extreme hot weather. And we know from our empirical work that those days of extreme hot weather are associated with reduced output. And so we can use our empirical estimates along with these climate forecasts to figure out how manufacturing output might be affected in the future as a result of climate change. And so we think that current extreme weather causes firms to suffer about 2.7% per year losses in output. But that by the end of the century, those losses in output might amount to as much as 9.1%. So more than tripling the losses in output in the manufacturing sector as a result of extreme weather from climate change. And so this is one of the ways economists are trying to assess the cost of climate change. And I'll speak to another effort to assess the cost of climate change in another study that I'm doing with the same graduate student, Philippe Kabor, and a colleague, Catherine Derry Armstrong. And so we know that climate change is expected to increase natural disasters, in particular things like floods and wildfires and extreme heat periods. And in this study, we're trying to use data to try to understand the costs of one of these natural disasters. We're looking at the Slave Lake wildfire in Alberta in 2011, which at that point was the second costliest natural disaster in Canadian history. And we basically use data from the Longitudinal Administrative Data Bank. This is data that allows us to follow individuals over time. And we compare individuals that were in Slave Lake at the time of the wildfire with similar individuals that were in other towns that weren't affected by the wildfire. And so what we see in this graph on the right, which summarizes some of our results, is that prior to the wildfire occurring, these individuals kind of had similar economic trajectories. But then following the wildfire, the individuals that were in Slave Lake experienced a marked decline in income. In fact, we estimate that on average for the 7 years following the natural disaster, income of people that were in the Slave Lake area at the time of the fire was reduced by over $4,000 per person. And that's a really serious and significant loss of economic welfare, and is a portion of damages from these kind of wildfires that hasn't really been counted in prior assessments. And we think, based on this information, it looks like it could be an important part of the overall cost of natural disasters. Okay, so that's a kind of a really quick snapshot of some of the research that I've been doing over the last few years in the research data centers using the confidential microdata. I just want to finish with a couple of reflections on this data. First is that most Statistics Canada data, most of the surveys that are collected or the administrative data doesn't directly pertain to the environment. But I do think there are opportunities to use the existing data to better understand key sustainability questions. And I hope I've tweaked your interests or your ideas for your own research using some of these information. Data sets that I'm particularly enthusiastic about are this longitudinal administrative data set that allows us to understand a number of outcomes for individuals that happen over time. I think Statistics Canada has also undertaken a number of linkages between data sets that allow us to maybe better understand environmental outcomes, like linking, for example, the community health survey to the census. And then I'm also enthusiastic about the firm level data, which I've used a couple of times and which are coming to the RDCs this year, I think. I'll just finish. I noticed I did have a few seconds left with a couple of things that I think would enable better research or more research on sustainability issues in the RDCs. First, I think that, like any good data nerd, I think we need more data. And in particular, I think we need more data on energy use and more data on environmental outcomes in general. So our main sources for energy and environmental outcomes at the household level are Households and the Environment Survey. There has been an effort to incorporate household level energy use data in the past, but it's really been spotty. And I think it would be great to see that initiative continued and to be rolled out more broadly. It would be great to have comparable household energy use data over time at the household level. Likewise, at the firm level, the Survey of Manufacturing Logging collects data on value of energy expenditures, but not data on the actual energy consumption. And so that's a real gap in that data set. It would be nice to have more consistent questions in our surveys year on year. In some cases, there's changes in the wording of questions, or some questions are asked in one survey iteration and not in the other. That makes it hard to do analysis that requires consistency in those questions year on year. It would nice to see sustainability research be an input to instrument design at the outset. So I think that would be something where it would be great to see researchers more involved in the design of survey instruments. And then a couple of sort of administrative issues. I think it's time to update some of the memory and the computers of the RDCs. It's getting hard to use big data sets like the longitudinal administrative data set, which is a big data set and often bigger than the memory of the computers of the RDCs. And it would be great to have easier incorporation of user-generated software. For example, packages in the various languages are difficult to include in the RDCs. I think it would be great to see that hurdle be resolved. Overall, I've had great experience at the RDCs, and I hope this presentation whets your appetite for more of that kind of research. Thanks very much.
Good morning. I'm going to talk to you about the work of FAO in supporting national statistics offices in countries in the uptake of Earth observation data for official agricultural statistics through the FAO EOSTAT project, which was launched in 2020 under the leadership of the Office of the Chief Statistician of FAO. So nowadays, the conditions for the use of Earth observation data for agricultural statistics are very favorable. In fact, we have availability of high-resolution images, which are free and open source, provided by the Copernicus program of the European Space Agency, which add on top of the Landsat program of NASA, which provide then access to historical archives of images. And this allows for constant monitoring of the crops. In addition to this, the rise of cloud computing platform, which provide access to Earth observation images, further facilitates the use of such technology. Despite all, the uptake is still quite low in countries, and this is due to a series of barriers. First of all, the pre-processing of the images is quite complex. So how to make those images, which are often heterogeneous in their quality, in the acquisition date, due to the presence of clouds, that's quite a task. So how to transform those images into consistent time series, and so the production of the so-called data cube is quite complicated. That's the first barrier. Second barrier is that models used to classify images into crop maps, they require in situ data, so data gathered in the field for the training and validation of those models. However, the availability of such data is still scarce, and when the data is available, the quality of the georeferencing that was used can be of low level, which then impairs the accuracy of the model. Thirdly, models that are calibrated in one area and for a given agricultural season, they perform poorly if they're used to predict crops in different areas and over different periods. So as a result, there is a need to gather in situ data for every new agricultural season, and the transferability, let's say, of the model, of the learning of the model is still quite limited. Finally, the lack of user-friendliness of existing Earth observation platform requires very high skills in programming languages, and this is another barrier. Finally, data confidentiality. So countries are not really comfortable in sharing data, confidential data, which includes coordinates of the location of farmers onto cloud platforms. So that's another problem. So how does FAO break through such barriers? Well, first of all, talking about the general approach is through innovation, is through training, change management, and international partnership. In fact, we work directly with the NSOs in the countries, plus a group of international partners who are internationally recognized for their work in this area. So the Université Catholique de Louvain, the UN Big Data Group, the European Space Agency, the Group on Earth Observation, and others. And the EOSTAT project, by the way, is being already implemented now in 4 countries: Senegal, Uganda, Afghanistan, Lesotho, plus it's in inception phase in other countries in Africa and in Latin America and the Caribbean. So how do we overcome such barriers? So first of all, we develop full solution that allows for the automatic pre-processing of the images and the analysis of the pre-processed images, transforming them into crop type maps. We rely on 2 main tools: the Send2Agri toolbox, which was developed using funds from the European Space Agency by a large international consortium. FAO contributed to the definition of the requirements of the toolset. Or we also work on with the EOSTAT Crop Mapper software, which was developed by FAO in collaboration with Hydro Solutions, using instead a Google stack. Secondly, we address the issue of data security by collaborating with the UN Global Platform, which ensures the highest and most sophisticated security protocols so that we can ensure confidentiality of the data. Plus, the UN Global Platform allows for low-cost storage and computing power, and it's a scalable solution, so we're able to deploy rapidly for new countries which join the project. We are able to deploy the Send to Agri toolbox quite rapidly. Third, we deliver customized training programs which address the key aspect of the production chain that goes from the Earth observation data through the crop maps and then finally the crop statistics. And third, we develop novel methodologies for crop mapping and land cover mapping that can cope with the scarcity of ground truth data and use Earth observation data to optimize survey designs and protocol. Finally, we facilitate the access to ground truth data, which are supported by the AGRIS program under the 50 by 2030 framework. This said, I'd like to show you some results from countries. So starting from Senegal, we collaborate there with the DAPSA, which is the Directorate pour l'analyse et pour la prédiction statistique agricole. So it's the division that deals with agricultural statistics within the Ministry of Agriculture. So they shared with us some 16,000 coordinates stemming from the Agricultural Survey 2018, because we could not gather any data in 2020 due to the COVID situation. As you can see from this chart, the distribution of samples per crop type is not really balanced. So we have a groundnut which is overrepresented in comparison to the other crops, followed by millet. This, of course, will create some problems as we will see in the prediction of the crops. So the first work that we did was to filter out coordinates which were ambiguous, which were not representing crops, and then we just kept those GPS points which instead were considered reliable. And then from the points we managed to develop the area, so the polygons that then were used into the training of the random forest. So the random forest then was used to produce the crop mask, which indicates areas that are under active crop and areas which are not. So in black is the active cropping area. And from this crop mask, then we generated the first crop type map, dated 2018. I'd just like to show you some details of this map. So it's interesting to see how the map is able to recognize the plot's boundaries, and this validates that Sentinel-2 data can actually be used to monitor crops at the plot level. You can see here we have irrigated plots, and on top in yellow is the predicted crop from the crop type map. So this map was then reproduced for a second time after further post-processing of the in situ data until we reached a satisfactory accuracy, which was almost of 80% accuracy. From the crop mask and the crop type map, then the statistics were extracted. It's so-called area indicator statistics. The aim of this crop area indicator is not really to replace or to be equivalent to the agricultural statistics, to the official one, as it is derived from Earth observation data, so it is a bit less accurate. However, the indicators have the advantage of being directly derived from the crop maps, so thus they can be available much before the official statistics. So they can be available during the season, before the harvest, whereas official statistics usually become available at least 6 months after the harvest. Based on the cropland mask, so the following crop, no crop indicators can be derived at national and provincial level. And using the crop type map, instead, this type of indicators can be extracted. So the areas of each crops at national level or at, of course, subnational level. The accuracy assessment of the crop type map showed quite a good accuracy for all the crops, but still with a slight overestimation of groundnut and millet. And this conclusion is also confirmed when we compare the statistics, especially for millet, with those official ones published by FAO-Stat. And the explanation comes from the fact that the cropland mask, which overlays the crop type map, is impacted by errors, yet the area indicators of the other crops seem to be really close to the FAO-Stat, which are taken as reference. Regarding the training, so capacity building, 4 trainings were delivered to DAPSA on the general introduction of the Sanctuary and the UN Global Platform, on best practices on the field campaigns on how to integrate Earth observation and agricultural statistics, and third, the technical training on the hands-on on the Sanctuary toolbox, and finally, on the use of the output. So how do we use crop type maps to derive statistics? Next steps for 2020. So we're going to fine-tune the crop type map and crop type map dated 2018. Now we're going to integrate best practices georeferencing within the new National Agricultural Survey in a pilot area. This is happening as we are recording this video. So we're going to develop the new national crop type map, and this year also the crop yield map as of 2021. And we're going to switch the technology from the Sanctuary to the Cent4Stat toolbox, which is an evolution of the Sanctuary. It is more accurate, and it also includes the module for crop yield forecast. Another example from Afghanistan, so in collaboration with the National Statistics Office, the NSCIA, who provided georeference data, so 2,500 in situ samples for rice and 934 in situ samples for wheat, which were collected in 2020. So for Afghanistan, we used a different approach. We first extracted the crop phenological stages from the Sentinel-2 annual time series so that we could identify crop-specific growing characteristics. And then at this specific stage of the crop growth, the spectral band values of the Sentinel-2 data were also extracted, and these are referred to phenospectral features. Basically, the key aspects of the key steps of the growth of the crop that we're interested in is basically the green up onset, the green up phase, and then the maturity onset, the maximum peak of the vegetation, and then the senescence onset, the senescence phase, the maturity onset, and finally the dormant phase. So in correspondence of these steps, we have been recording the values of the spectral bands, and we're using these, of course, as a training features for the subsequent classification algorithm. So the crop phenology map was our first output, and this is indicating us areas where the crops reach the peak in the first part of the year, crops that's in green, crops that reach the peak in the second part of the year, that's in purple, and crop instead which have 2 peaks during the year, which is indicating of double cropping, which is this light cyan color. Using the phenology map, then we could produce the crop mask, indicating where do we have crops and where we don't have crops, active cropping, of course. And further than this, using an enriched in situ data set, we could produce finally the crop map. Using, of course, just the data that we were given. So we were given wheat and rice, and plus we could derive some data from cotton. So we could push the prediction onto a total number of 6 classes. So wheat single crop in yellow, rice single crop in green, in blue cotton single crop, and in brownish wheat rice double crop, and then in the light red and dark red double crop others and single crop others. So we know that there are crops, but we have no information what type of crops those are, given the type of in situ data that we have been given. The accuracy of the map was quite high. As you can see, we had an overall accuracy of 95%. So 436 data points were retained from the data set as a validation data set. We also used Planet data together with Sentinel-2 data in the case of Afghanistan on request of the country. Again, a training program was developed featuring a series of 3 online webinars. We managed to deliver one. And then, as you know, because of the dramatic changes in the political aspect in Afghanistan, we had to stop the project. So at this time, the project is on halt. We hope for the best for the country, but we can't really make now any forecast on the next steps of the project, unfortunately. Third is our use case on the SUTO. In this case, we've been working on land cover mapping instead of crop type mapping. And jointly with the Ministry of Agriculture, FAO has developed a new methodology that allows the country to produce annual land cover maps in a semi-automatic way. So in 2015, a first baseline land cover map was produced, which was very detailed, and it's shown here on the screen. And such map was based on a quite resource-intensive methodology, which implied the acquisition of commercial 5-meter satellite and the national orthophotos and the punch sharpening of those images. Secondly, the definition of a custom cover legend. And third, image segmentation, so the classification of those images in smaller polygons which have homogeneous spectral characteristics, and then the visual interpretation of over 1 million polygons from a team of 36 people who were labeling each polygon with this respective class just by visual interpretation. And of course, this methodology is not really sustainable if one wants to reproduce the map on a yearly basis. So the challenge was how to overcome this issue. And so a new methodology was developed, so radical change. So first of all, we relied on Sentinel-2 data, so on free and open source data rather than commercial data. And this allowed us to produce a so-called data cube. Regarding the training data, what we did, we took data from the old 2015 land cover database, and additionally we collected training data in situ. And then we produced the land cover product, the new land cover product, by using a random forest. And now the solution is automatized because new training data can be extracted from the latest land cover map and be used to classify the data cube with the new data with the new Sentinel data for the future years. And this allows for a very low-cost solution. Of course, it is always good to collect some training data in situ when possible. However, this is not a hard requirement anymore. So as a result, now we have the 2020-2021 map, and now we're producing the backwards in time. We're producing the maps from 2016 until 2021. Here you can find description in details of the differences in the two methodologies, and also an explanation of the overall process. So what was done with the old land cover map, how the data cube was built, and how training data was prepared from existing data, so the old land cover map or new data gathered either in situ or either from the crowdsourced. So there is a very detailed description in the presentation. And I'd just like to conclude with some key points for reflection on how to improve the uptake of Earth observation data for official agricultural statistics. So surely there is a need to collect more training data in situ through optimally designed conservative surveys and the use of best practices in georeferencing. So this seems to be quite a clear need for countries to have a way to just gather the right amount of data, so not too much data, but use optimally designed surveys based on stratification so that they ensure an exhaustive spatial representation of the various patterns. Secondly, more research work is still needed to develop algorithms that can leverage on old training data, so from older seasons, to accurately predict future crops, crop yields, and land cover types, and also in different areas. And third, the need for more user-friendly solutions that are integrated within the Earth observation cloud platforms that are now available, which can also and also supported by optimized workflow that can ensure low running costs. This is the last point. So I hope you enjoyed my presentation, and thank you very much for your attention, and I hope to receive your questions, be able to answer them. Thank you very much.
Well, thank you to our presenters. Those were excellent and very detailed presentations, a lot of information there. Unfortunately, Lorenzo hasn't been able to join us, but we do have Briony and Nicholas here with us. We haven't received any questions in the Q&A box yet, but I welcome those from any of the attendees who'd like to add them in. In the meantime, what I think I might do is ask Briony and Nicholas to come on video so that we can be on video together and pose a few questions. We have only about, we have under 15 minutes left to go. So we'll put some questions in there. And, you know, at the risk of asking more applied questions rather than sort of academic or research questions, I want to pick up on some points that you both mentioned on sort of use of the data and implications for people and for communities. So Briony, you spoke to some of the topics that came out of the session that our organizations did jointly together a few months ago, and you highlighted some takeaway points about the role of local communities, the importance of putting together committees of stakeholders, the important role of civil society organizations, and not reinventing the wheel, but building on what exists. And I think what you were getting at there is the way in which it's really exciting to see how new technology, in your case, certainly technology from space using satellites, Earth observations, are improving our ability to analyze and model and predict what's happening with climate and the environmental impacts on the Earth and how to adapt and mitigate to that. But at the end of the day, people do matter, and they matter a lot. And indeed, Nicholas highlighted that in his presentation. And it is data often about people, or it's data that will affect people. And I would love to hear a few reflections for you beyond the takeaways that you highlighted in your slide, the sort of like concrete steps that you've seen work well, perhaps, in some of the work that Space for Climate may have done to sort of engage people at community level or affected people. While you think about that, Nicholas, I will pose a question to you. This angle of the socioeconomic impacts of climate or environmental regulation and policy is interesting. And what I thought was such an interesting takeaway is that your research is maybe myth busting, right? Or it's maybe challenging some common wisdom or common views about what those regulations might result in, and some fear, indeed, perhaps, around some of those regulations. And so I'm wondering about, particularly using your British Columbia example, because it's older and we've seen more time pass since. How has that research been used or reflected upon by policymakers, if you've had the opportunity to do that, or how have people reacted to the research, and what changes might that have been brought about? Again, we're like sort of coming back to like, what is the value of having this data and using this data to make meaningful changes in the context of climate and sustainability, perhaps. So, Briony, I'll go to you first, and Nicholas, you can then reflect on my question.
Yeah, really interesting question there, Jenna. So some reflections on what's worked well. One of the initiatives the UK Space Agency funded was its International Partnering Programme. And actually the example I gave in my presentation, RESAT, that was the Institute for Environmental Analytics in the UK, working directly with members of the government in various small island developing state nations, and then parts of the energy sector as well. So what worked well with that was there was quite a specific sort of questions requiring sort of quite an amalgamation of data intelligence, not just satellite data and analytics. And the concept was basically co-developed, and the questions that needed to sort of challenge the data set were coming directly from the people that actually wanted to make decisions. So then it sort of then worked backwards as to, okay, how do we then amass the information and produce the analytical software that's going to help with that. So that's an example. I think what I get at then is you have to think about the kind of procurement chain that actually enabled that. So the Space Agency in this instance actually had an initiative that really encouraged that kind of sort of partnership working in that kind of co-development stage as part of the funding, that you didn't have to have your proposal already, know exactly what you wanted to do and then bid for the funding. That was part of it. And also that part of the activities that were funded were the knowledge exchange part and keeping those discussions going. And then also there are a couple of different stages to it, so different phases. So they were able to apply for funding for a second time around, and then they took it from the first example that they did, and then tried it out then in another sort of, I think it was 4 or 5 different Pacific islands, and were able to evolve and iterate it according to different countries' requirements that they were then working with. So I think that's an example where when we've done something that works well, how do we then try and do that more? And I think that some of those examples, and there will be ones also through, I was going to mention, and because we had the FAO talking about the EcoSat program, also about GeoGlam as well, which is run by the group on Earth observations. And in fact, there's even a Canadian example, I think, on canola. But when we do those well, it's quite small in the space world. And what I'd like to see is, how do we get those examples where we've learned about what works well in that co-development process for bringing minds together with the kind of the data bods, as it were, into the sort of climate finance, the kind of adaptation fund, etc. Indeed, one of the projects that was also in that IPP program was called Common Sensing, and one of the things it did was actually churn the data sets to help with funding applications for climate activity. So I think there's that aspect as well. And I think the last thing I was just going to mention, because they haven't been mentioned much, but is the role of the third sector organisations that often are providing that brokerage. And one of the things I'm sort of challenging myself and the Space for Climate group with sort of going forwards in some of our work with GPSDD is when we're trying to reach out to Indigenous groups who perhaps have their own different ways of managing the land, and will be having to adapt those also to changing climate, and will be very data literate. There'll be generations that have gone through also university, etc. How do we make the data sets and this willingness to work together sort of more accessible? I think for me that's the challenge. I think we've got great international willingness and great investment actually in data sets, but not so much willingness to fund these kind of brokerage platforms, and it takes time, and that's something Space for Climate welcomes working with GPSDD on, because GPSDD brings the in-country connections, does that work in country to find out the knowledge and information requirements and the existing capacity levels, because sometimes there's great expertise in particular areas, and maybe the issue is actually cloud computing infrastructure or something like that, and we really value that. We don't want to replicate that. What we want to do is bring our experts to the table to help where the gaps are. So we've found our way, I think, quite well with GPSDD, and we're looking forwards to how we progress that. But it's small little activities. I found this when I worked with the UK Climate Impact Programme. It's sort of small projects, and I think the challenge for us all here today and those researchers listening in is, how do we scale this? What are the sort of socio-technical transitions? What are the sort of systemic changes we need to make to procurement frameworks, to all sorts of things, to help that. So I'll be quiet now, but yeah, I'll be really interested to see and hear what some of the researchers listening today are thinking.
Yeah, thanks, Briony. We're sadly a little short on time, but Nicholas, I'd love to hear your thoughts to the question I posed, and indeed any final thoughts you might have reacting to Lorenzo's presentation from the FAO and any of what Briony already said.
Okay, thanks, Jenna, for your question. I'll start out by with your question, then maybe some reflections at the end. So you asked about how policymakers are able to use some of the kind of findings, retrospective findings on evaluations of environmental policies, and in formulating new ones, I think. And so certainly, I think that does happen. The case study that I mentioned, British Columbia, has certainly been held up as an exemplar for other regions developing climate policies. I think, Briony's in the UK, which is also held up as a kind of exemplar for other states and regions to follow in developing climate policy. And I think, the empirical evidence out of both of those regions is powerful in kind of mobilizing support for climate policy. So the kind of fears that I think policymakers have when they implement stringent greenhouse gas policies are multifold, right? They're concerned about income losses, which is something that I was presenting about. They're concerned about potential trade impacts, right? If the UK or BC is implementing a climate policy and other regions aren't, then there's real fear that there'll be migration of industry. They're potentially concerned about job losses and transition across sectors, or inability for workers to transition across sectors. And so certainly, I think as we develop more, as we have gone through this policy development more and have learned from previous policy iterations, it certainly helps to alleviate some concerns about implementation of climate policies. And it also helps us to learn about what kind of climate policies work and what ones don't. So as an example, the EU emissions trading system was one of the first forays into market-based environmental policies, and definitely the kind of social science research that came out of that policy has informed future generations of climate policy making, such that the recent climate policies that have been passed in Canada have responded directly to some of the concerns that were I guess arose from that first generation of environmental policymaking or climate policymaking. So certainly, I think that this kind of research does get used in formulating new policies and in lobbying for new climate policies. It was really interesting for me to hear the other two presentations, because I'm jealous about the data availability in the natural sciences, the climate sciences, compared to what we're working with in the social sciences. I mean, we are really not gathering environmental social science data systematically. So we are in a world, I think Brianna pointed to this, the first generation of climate services was really, piggybacking on other projects. And that's where I feel like we are right now. We're using the labor force survey to understand environmental trends, because that's what we have. And so I think that, as we go further and further down this transition to a zero carbon world, it's really going to be an imperative to start generating better data about where the bottlenecks are and about what the holdups are, and what, where the transition is moving well and smoothly and where it's not. And right now we're really fumbling in the dark or are piggybacking on other socioeconomic data to try to understand those trends. And so I think this is one of the interesting things that came out to me from this set of presentations, and something that I think is going to be instrumental in facilitating the transition going forward.
Great. Thank you very much to you both for those insights, both in terms of experience and in terms of research. I think, Nicholas, that takeaway is really loud and clear about social science data, the need for it to understand environmental change, and a sort of I think a good message to take away, as well as some of the others highlighted by Briony about co-creation and the kind of the implications for all sorts of other processes, whether it be procurement or policy frameworks that allow for sort of forward movement. Also, in his absence, thanking Lorenzo for that, for highlighting the work that FAO is doing in the developing world as well. And that's one of the things we strove to bring to this session, was to bring that global perspective and to understand the sort of the different experiences, but also to highlight what is going on and the very exciting work. So thank you so much to everyone. We have a thank you in the chat. Although we had, I think the panelists would be very open to receiving any questions afterwards and responding to them. Thank you to all those who joined us today. And thanks to the CRDCN conference organizers. It's been great, a great session, and I think we'll wrap up now. Thank you to all.
Thank you.